I'm going to go ahead, and it looks like we have no sharing right now, so I can go ahead and hand things off to Aaron. So, Aaron, take it away.
Oh, thank you. So let me the screen share this desktop. Oh, of course it starts backwards. Okay, and everyone can see my slides. Cool. So I want to talk about content delivery networks, or CDNs. My joke tagline is, are they a sports car or are they a semi-truck? Which hopefully I'm gonna kind of convince you one way or the other by really toying with that metaphor a lot. Sort of saying, like, who am I? I'm Aaron Lee. I also live here in Urbana. I like taking pictures of things in photography. I've been a software engineer and an SRE for quite a while, which means I've worked on around CDNs for a long time. So I've kind of seen how they've changed over time and what is kind of their I don't want to say state of the art, but their best usages now. And my disclaimer for this, like, this has nothing to do with my former employers. If you know who they are, they're not, like, I'm not pushing them into products or saying anything that is their views. So we're getting right into the talk. So is it a sports car? Is it a semi-truck? And the first thing you have to ask for that is, how does the web work? And Ben, you sort of touched on this. Like, you had a drawing just like this, where it's like you make a request, it goes to a web server, and the web server spits back the web page. And I'm pretty sure we all know that's not how it works at all. Like, there's totally so much more that goes on underneath, like a whole bunch of different requests that happen. But a lot of the problem is, even on the routing layer, it looks like this, right? So you have you make your little request, and it goes out to a number of different routers, and it's going through different networks, and all the way off to another web server before it finally comes back. And there's a lot of reasons that this can be slow. So the one that everyone kind of jokes about is the speed of light. Like, if your web server is in Europe and you're sitting here in Illinois, it's going to take 100 milliseconds just for electrons to get there and do something before they're even on their way back. And so that's like best case scenario. Every time you do a hop, you're going to add a little bit of latency. As this diagram so wonderfully shows, the rarely ever takes a straight path. You know, if you're sitting here on AT&T in Urbana and you want to load up like illinois.edu, I've seen that go through Chicago before. Why? But that's just what the network wants to do. And so a long time ago, I had this original idea. How do we solve this? Well, with caching. So we add a little cache in there, much closer to the users. And the thing is, you don't have to put these caches everywhere. You don't need a huge number of them because the networks themselves all come together in certain places. So you have these special data centers called interchanges, where there's a special room called the Meet Me room, where AT&T plugs into AWS, and T-Mobile talks to Google, or whatever. And in these rooms, you have access to a whole bunch of networks. So they also tend to have these cache machines there, but that the CDNs run. And so they're kind of expensive to get in data center space near there, and they're pushing a whole bunch of traffic. So what they do is they build these machines really, really, really big. There's running as much RAM as the state-of-the-art CPUs can address. They have SSDs. They'll have network cards that are 40 gig or 100 gig, and they'll saturate those with the amount of bandwidth that's going through them. It's incredible to see how they build these things, and the routing they do to get the distribute load across all these machines. And that's well beyond the scope of this talk. I can definitely tell stories about like how CDNs are built. They're really cool, but that's beyond the scope of this. So it's a state where, like, really 10 years ago, 15 years ago, we had these machines spread everywhere. Akamai was a company that had the big name for CDNs. And with these machines spread everywhere, we still had some latency issues. And so we've gotten around with things with local caching, HTTP2s, a lot of little tricks people are doing to get around the latency issue. But we have this giant web server sitting in front of our our site. It asks like, what other problems does that solve? And we have this enormous web server there. And the first one is just like, it takes load off of your infrastructure. So as everyone knows how cache works, if you make one request into the cache looks and says, oh, do I have this web page that's being requested? No, it's not in my local store. Let me go back to the origin, is what it's called, the origin of this data, pull it into my cache node and serve it back. Next person comes in with the same page they're looking for, and the cache will look and say, oh, it is in my local storage, I can hand this back to you. Well, that's one less request on your origin server, which like one request isn't a big deal, but if you're, the New York Times and, some big news event happens and everyone clicks refresh, that can be a huge inrush in traffic, which if you're running, a site that you don't expect this on a regular basis, that can be a big issue. But for someone like, Fastly or Cloudflare, if my blog goes to the top of Hacker News, it will definitely knock over my little $5 droplet, but Fastly's not going to notice it in their metrics. Like it's just, they push so much bandwidth, they push so much requests that it's not an issue for them. So like having this little buffer in front of you is super important. And so because of that, like network, the meet me rooms I was talking about earlier, you have often cheaper bandwidth, depending on who your host is. It can, like Netlify, they charge something like 20 cents a gigabyte, and you can get 5 to 8 cents a gigabyte on other CDNs. Again, for my blog, like I'm not pushing enough traffic to make the difference with that price, but for some sites that I think a huge ordeal. It's one of the cool things if you configure it correctly, it'll remain up if your site goes down. So if you it can't reach the CDN can't reach your origin, it'll keep serving out the last page. So you get this kind of like buffer of like, oops, my deploy didn't go correctly. Let me roll back real fast, and like there'll still be something being served. And then one of the cooler things they can do is a lot of them have so much bandwidth and so much control over the network, they can actually absorb really, really big DDoS attacks. Like I've seen them in multiple hundred gigabit DDoS attacks being absorbed without affecting sites, which is really cool. But the asterisk on that is that definitely won't be free. And so if you cause enough trouble for a CDN, they're going to ask you to pay up or take a hike. So that's one of those caution things. Then for this, we're going to ask like how you would configure a CDN, and it's kind of different for every CDN, but there's some basics around here. So the first one, you go sign up for them. Some of them it's more complicated. If you're using S3, you can go right to CloudFront and you click a button and boom, you're using their CDN. Or you have access to their CDN. Others, you actually have to go and configure what your origin looks like and set up authentication for the CDN front end to be able to request from your servers. So after that, what's going to happen is your CDN is going to have an actual different URL that you're going to go make requests from. Again, I'll show later a little example where that's not always the case, but you're going to have in your web application to rewrite all the URLs to use the URL for the CDN instead of for your local machine. So that's something to watch out for, where it can be a sort of an issue to have your production machine serve different URLs than your local for your development environment. So I just want to caution everyone around that. So we can go actually look at some sites that are using CDNs, if I can find my pointer. Okay, so I guess the first site we'll look at is Craigslist. Oldie but goodie. It's really simple. They're using things really, really simple URL layout, and they have purple Jeeps today, apparently. So this one, refresh, reload. And if we can see down here, the very first request is going straight to chambana.craigslist.org, and it's coming from their response headers actually say it's Apache, and you've got cookies and a bunch of other stuff in there. But if you go and look at where the images are coming from, they're all coming from images.craigslist.org. This is their own service that they run, but it's super simple. You can see it's a different URL, like it's a different domain that they're sending to. So you're sending different cookies than you would be sending to the chambana.craigslist.org. So it's kind of a separate. And this is kind of the simplest that you can do for a CDN, and because it's got the separate cookies, you can refresh and everything comes out of the cache instead of being because of your local cache instead of going back to hit the CDN. We'll talk about in a little while that cores can be a nightmare with CDNs if you don't do them correctly. So the second one I want to show is Stack Overflow. And as you would expect from someone doing Stack Overflow, they do this correctly. So they have their CDN here. Like one of the interesting things that they do for their root page itself actually comes through CDNs. If you see it says via Varnish down here, Varnish is an open source CDN. So they have even their top level request that sends like all your auth information and everything through, it goes through the CDN. And they do that for a couple of interesting reasons, not for the latency issues, but for the other reasons that I was talking about. If they have an issue where they have a bad deploy or something, then they don't have to change DNS to change to different machines. They can, they just make a configuration change in the CDN, and that CDN actually sits in front of, Varnish sits in front of their web service. And then if we go a little further, they do have another CDN. You can see it says has Varnish, and it has some CDN information. So this is probably hosted Varnish that they're using, which is cool. Then we go for digital photography review, which is kind of a nightmare with all the assets they load. And we can make a good guess that they are on CloudFront because they're owned by Amazon. So, and if we click, we can see this actually, yes, they do have a bunch of the Amazon headers. But if you notice here, they're also sending their root page through the CDN, and it actually reports that it's a miss. It'll be a miss on every one because I'm logged in. So it's sending back the actual, like it's rendering content and sending it back through the CDN to me. So, so then if we go, we see later on, they do actually have hits for some of their other data. This means it's not, it came out of the CDN and didn't go back to their origin. I think it was Gravatar. Never mind. Some of them will actually give you a lot of, yes. Sorry, the sstatic.net is the CDN, or the domain name that Stack Overflow has set up for their CDNs, but it will actually give you the number of cache hits for every asset that you load. So if you go through there and you find a page that has something that gets an image and it gets loaded a whole bunch of times, like it'll actually tell you, this is something that's being hit a lot. This is something that's not being hit a lot. This is it's interesting that they're leaking this out to the rest of us because hit rates is a really big deal with the CDN. So if you have a CDN and you're serving assets that are kind of on the long tail, like that, get accessed every few days, something, you're actually adding latency to those because every request is a cache miss. And it's just going to go to the CDN. The CDN is going to say, I don't know what this thing is. I'm going to go back to the origin, get the original file, hand it back to the user, and then if nobody else comes and looks at it, it's going to expire out of the cache eventually. And then the next time someone comes to request, you're actually going to have that same extra latency of going to get your data. So it's especially something to watch out for if you have user-generated data where you have like you're letting users upload files or something, you're pulling those through the CDN, and it's something that somebody doesn't look at for, they upload it and like people look at your TikTok video a whole lot for one day, and then it falls off and nobody sees it until 6 months later, where one person goes to load it, and then it has to be pulled through the CDN again. If you have that long tail of people constantly pulling these like one time, you can have a lot of expiry issues in the CDN itself. So that's where having this data, this hit rate, is a important information to have. Cool. So let's go back to the presentation. So there are some gotchas to using a CDN. So one of them is, as everyone knows, one of the hardest problems in computer science is cache invalidation. So if you make changes to a file that's on your origin server, you do a deploy or something, you have to have a way to either have the expiry, like you have to wait out the expiry times on the CDN, or you have to have a way to tell the CDN, hey, go expire all these caches for me. That was Fastly's big selling point for a long time, was that they were the only ones who could do, on the order of millisecond cache expiries from their CDNs. And it's, I'm not sure what the state of that is at the moment, but it's something to definitely be aware of, especially if you have, like I said, a bad deploy, or you have content that changes very frequently. Like if you have a news website, you normally publish once a day, and it's not a problem if you publish it, it goes live, whatever. But like some breaking news happens and you want to update your site, well, now you have to wait for an expiry to happen. So one of the other things, if you have some weird headers you're sending, authentication headers, you're asking for weird content types, you can have cross-origin resource sharing, I think it was called, can cause a pre-flight request. This is where it just your browser asks the web server, hey, can I use this thing out of my cache? It doesn't send all the data, but it will send a round trip request to do this, which isn't an issue for one file. But if you have like let's say a Slippy map where you're Google Maps and you're dragging the map, and every time you drag the map a little bit, you have to load a whole bunch of tiles, and every one of those does a pre-flight request. You can actually generate a whole lot of latency, not from data transfer, but just from individual requests where your browser is constantly saying like, hey, can I use this? Hey, can I use this? Hey, can I use this? So that's something to be aware of. And then one of the big ones is the hit rate. So if you have a really low hit rate, you can actually introduce a lot of latency. And this is, something you can get from the use the console on your CDN. We'll have a metrics page that says, here's what your hit rates are, here's what your lowest hit rate assets are. So yeah, so those are some gotchas. So CDNs can introduce other problems. One of the big ones is that it is a complex, like it's one more thing in an already complex environment. So you have to worry about like the bandwidth for the accessing the CDN, the logging, if you have DDoS mitigation, all these things are, it's one more thing you have to deal with. It's, my caution is like, you do have to have and is this something we really need? It's an analysis that you have to do. So once you tack on all these extra features to a CDN, when you're just selling bandwidth, it's not an issue. But if you're doing things like having it do authentication for you, which some of them can do, where they'll manage users for you, and that is that can get expensive. They have something called a web application firewall, where if you're passing all your web application traffic through the like all your post requests and all your put requests through the CDN as well, they will analyze those for unusual traffic patterns. And if like you have one URL that suddenly gets a gazillion post requests, they'll start blocking them. But those kind of things are expensive as well. I mean, they're cool because they can, it's an extra layer of security where they can catch stuff that your app might not, like you might not notice in time. And then CORS is always an issue with CDNs. So going back to answer that question I posed at the beginning, is it is it a semi-truck or a sports car? I'm going to say they're more like a semi-truck, but it does have this big caveat that if you don't have a loading dock and someone with a forklift, you might be better off the little hatchback. So if you have a big Dell server plugged in the university network and you're deploying a site for a department, you're probably better off not using a CDN, just running it all off that server. But if you have a blog that has it's your cooking blog that normally gets 10 users a day, and Oprah tweets about you one day, like, you need to be able to take that traffic right away, or you're not going to get, like, you don't have 2 hours to go spin up a bigger instance. So in that case, it probably is better to have a CDN. And so that's my big thing. Is there's a lot of considerations with the CDN beyond just latency. They are really a giant web server that you can kind of sit behind. And so yeah, thanks for listening. I hope I kind of convince people that CDN is something cool to check out.
Very cool, Aaron. Does anybody have any questions for Aaron?
Or does anyone have any horror stories about CDNs? Those are always fun.
Aaron, do you have any favorite CDNs that you really like? I used Cloud. I just did the free Cloudflare CDN. I threw it in front of a WordPress site. I have to say I wasn't impressed by what it did. I didn't feel like it sped anything up. And actually, when I had a site outage, like the big pitch was Cloudflare would be like, it would hide that. And it didn't. I instead had a Cloudflare error that said unable to connect to the host behind it. And I don't know, I was very disappointed by it.
Yeah, so that's where Cloudflare is interesting, because they have their pricing definitely gets you in the door. But when you want to add on a bunch of the additional things like that origin shielding, what that's called, where they will they'll mimic your origin for you, so that if you do have an outage, or the other issue you can have with the CDN is that if the CDN themselves have a gazillion nodes everywhere, you can still have a huge influx in data. Like when you push a new piece of data, or you push a new asset that you see them, like all of the CDN, all the cache nodes are going to come to your origin to figure out what that piece of data is. And those things tend to be, that adds a nickel here and a dime there. I've had good luck with Fastly before, but their barrier to entry is like $50 a month. And I've also used CloudFront previously, but their biggest selling point is that if you have stuff in S3, it's super easy to just click a button and you're off to the races. The other cool thing with CloudFront is they'll integrate with like all the other Amazon. If they're managing your certs, you can use the same certs from, so you can like Route 53 will point to CloudFront, and it'll set up the subdomains, like the subdomain, it'll inject the cert into the CDN for you, which is cool. So the thing Ben was talking about earlier was Netlify is like, they are a build pipeline with a CDN in front of it. And so they'll do like the whole, you just describe what your build process is, and you point Netlify at your repository, and they'll take care of building the site, pushing it to their object store, and then setting that behind the CDN for you. And so you point DNS at Netlify, point Netlify at your repo, and give them your credit card number. That's it. So
I had a quick question. just what your take on. I've seen a lot of CDNs that are seemingly like image only CDNs, like especially with WordPress. There's all the plugins that serve up like WebP images and whatnot. Is there, I guess, is there a reason to use any of those, or does it make more sense to just use a full-fledged CDN?
I mean, if it's you kind of have to evaluate pricing. So I think some of those are cheaper than using something like Cloudflare, but it used to be that bandwidth for serving images was a big ordeal for web servers, and now with cloud servers, you're getting so much bandwidth that it's not so much of an issue, and it's request, like individual request load is as big of a deal as bandwidth, unless you're serving a lot of really big images. And so being able to take care of all the JavaScript and fonts and everything else that you want to serve from your site is usually a big benefit. So,
if you don't mind, I wanted to add on, because I saw those image
totally.
CDNs. They're actually getting around a different problem. It's really hard to get image magic with WebP already pre-compiled. So most web servers don't have that capability. Actually, it takes a lot of work to get that image magic or GD to have WebP. So that's what they're sidestepping, is you having to install a custom version of that. So they're just like, oh, we'll take those and we'll serve the images in WebP for you.
So I know that's another big thing that CDNs are selling now is, in addition to the WebP, image resizing and JPEG optimization. So like if you upload images to Airbnb or something, they stuff into S3 the full size images, and then when the CDN comes to get those images to display out to the users, the size and quality information is in the URL that it's requesting to the back end, and then the CDN grabs the images, does the image conversion for you, and sticks the converted image into its cache. And so that you, if you change anything in your front end where like you want, oh, I want this image to be a little smaller, I want it to be a different size or something, you don't have to go and redo your entire catalog of imagery. It's just the CDN goes and re-optimizes everything for you. And so, yeah, it's and I didn't realize that they would do that optimization along with it. So that's a really good point.
Any other questions for Aaron? Well, in that case, let's thank you, Aaron, very much for your presentation. If we could just
Thanks, everyone.